Welcome to our database assignment. The Vestavia Hills High School Library's website is used throughout the school by teachers and students. When conducting our usability study, we had students utilize the library catalog to complete simple tasks. In our database project, we took a look at the website's interactive login component, which was located in the Destiny Catalog tab. We decided to take a deductive approach by constructing a database based upon the library's existing website. The purpose of this tutorial is to demonstrate how to use the interactive component and to demonstrate the relational database behind the login function. When this video is over, you will be able to locate the login on the library's website, understand the relationship between each table of the database, and understand the usefulness of having a relational database within your website. A few weeks ago, our group developed a usability survey given to high school students in order to measure the library website's ease of use. We found that most of the students considered the library's website and catalog to be user-friendly, and so we decided to investigate what interactive databases might be used in order to connect students with relevant information pertaining to their library usage. Before we look closely at the interactive components of the website, I will demonstrate how students access the catalog. To get to the library's catalog, one must click the Destiny Library Catalog tab at the top left on the toolbar of the library homepage. Next, the user must scroll to the bottom of the page, and he or she must click the underlined word Here that directs the user to the catalog, which the library refers to as Destiny Catalog. The opening page of the Destiny Catalog does not appear to have any databases available for user interaction, so one must scroll to the upper right-hand corner of the screen and click the Login button. From this login screen, we can now see an interactive component of the website. We infer this function uses a relational database. Once students enter their login information, specific information about their library account becomes available. We contacted the librarians at Vestavia Hills High School, and they kindly allowed us to log in to their catalog using a sample student account. Students simply type in their school-generated username and password that they created in order to access their account. After logging in, students see the library's recently added books and popular titles. Then, to see personalized information, students must click on the drop-down menu in the upper left-hand corner of the screen. From there, the student has the option to see current checkouts, holds, and fines, as well as other information regarding his or her library account. For example, our student has 2 titles checked out, and he or she has 1 book on hold. Now, in order to take a closer look at how the library uses databases to interact with patrons, we created our own relational database with sample user data. We assume that the average student user of the website likely wants to use this database to see holds, current books checked out, and fines. So the database we created for this sample contains multiple tables. The first we created was Table 1, our main table. This table contains the student's unique identifier, the student's name, his or her grade, when his or her library card was issued, previous fines paid, fines that are currently due, his or her email address, and his or her homeroom. We also created a contact table which just uses the student's unique identifier, email address, and homeroom. The unique identifier field in this table uses the same unique identifier from the previous table, thus connecting our tables to one another. Our next table contains student unique identifiers as well as his or her fine status. If the student owes a fine, the box in the Currently Owed attribute is checked. In our final table, our only attributes are student unique identifiers and expiration date. If the box next to the student's unique identifier is checked, he or she holds a card that will expire within the calendar year. When considering the uses of this database, we created a one-to-one relationship between the student's homeroom and expiration status. Librarians could use this relationship to contact students via email or homeroom when his or her card was about to expire. Another relationship that library likely uses is a one-to-one relationship that connects the student's email, the expiration date, and fine statuses. This relationship could be used to contact students whose cards are expiring and that owe fines. Using relationships to pull data in different configurations is a key feature of databases. Databases allow us to store and organize information in useful ways. We used a deductive approach to demonstrate the types of information the library's website might utilize. Using a relational database to connect information would enable librarians to easily locate expired library cards and alert homeroom teachers. In addition, these databases allow students to stay up to date with items that are checked out or reserved on their accounts. Understanding how databases work on the back end can help us better serve as librarians on the front end. We hope this video shined a light on the purpose of databases and how they work. Thank you for watching our video.